In the 1930s, at the prestigious laboratories of Harvard University, a psychologist named Burris Frederick Skinner began a series of experiments that would fundamentally change our understanding of why we do what we do. He didn't just want to speculate about the human mind, he wanted to treat psychology as a hard science as predictable as physics or chemistry. To achieve this, he developed a piece of equipment officially called the Operant Conditioning Chamber, but known to the world today simply as the Skinner box. This device was not just a cage. It was a highly calibrated scientific instrument designed to isolate the variables of behavior. To understand the Skinner box, we must first understand the core principle Skinner was testing: operant conditioning. Unlike classical conditioning, where an organism learns to associate two stimuli, like Pavlov's dog associating a bell with food, operant conditioning is about the association between a behavior and its consequence. Skinner's box allowed him to measure this with extreme precision. The physical construction of the box was deceptively simple but functionally sophisticated. Inside the chamber, there was usually a lever for a rat or a circular key for a pigeon. There was a food dispenser that could deliver a single pellet or a drop of water, and often there were lights or speakers that served as signals. The floor was often made of a metal grid that could be electrified to deliver a mild, brief shock. The most important feature, however, was the cumulative recorder. This was a device outside the box that tracked every single action of the animal in real time, creating a continuous line on a moving strip of paper. If the animal did nothing, the line stayed flat. Every time the lever was pressed, the pen moved up one notch. This provided Skinner with hard, objective data, the rate of response, which became the gold standard for behavioral measurement. To analyze the data correctly, we must look at the specific schedules of reinforcement Skinner identified through millions of recorded responses. Skinner found that the way you deliver a reward is actually more important than the reward itself. He tested 4 primary patterns. First, the fixed ratio schedule, where a reward is given after a specific number of responses, such as every 5 lever presses. This leads to a very high and steady rate of responding. Second was the fixed interval schedule, where the first response is rewarded only after a set amount of time has passed, like 2 minutes. Interestingly, Skinner observed that animals on this schedule would stop working immediately after a reward and only start pressing the lever again as the end of the time interval approached, creating a visual pattern on the cumulative recorder known as the scallop. Third was the variable interval schedule, where the time between rewards changes unpredictably. This creates a slow and steady rate of response because the animal never knows when the window of opportunity is open. However, the most powerful discovery was the fourth schedule, the variable ratio schedule. In this setup, the animal receives a reward after an unpredictable number of responses. It might get food after 3 presses, then after 20, then after 2. Skinner discovered that this schedule produced the highest rate of activity and the strongest resistance to extinction. Even if the food stopped coming entirely, the animal would continue pressing the lever for a very long time, hoping the next press would be the winner. This is the exact mathematical principle behind the slot machine and modern gambling. It creates a powerful, persistent loop of behavior that is incredibly difficult to break. Beyond simple rewards, Skinner used the box to study negative reinforcement and punishment. In the laboratory, these have very specific definitions. Positive reinforcement is adding something desirable, like a food pellet, to increase a Behavior. Negative reinforcement is removing something unpleasant, like a loud noise or a mild electric shock, to increase a behavior. It is important to note that both of these are tools to make a behavior happen more often. Punishment, on the other hand, is the application of an unpleasant consequence to decrease a behavior. Through his data, Skinner argued that punishment was an ineffective way to change behavior in the long term, as it often only suppressed the action temporarily and caused unintended emotional side effects. He became a lifelong advocate for using positive reinforcement to shape society. A significant but often misunderstood chapter of Skinner's career involved his own family. In 1945, Skinner designed the Air Crib, a climate-controlled, glass-encased crib for his infant daughter, Deborah. Because of its appearance, it was frequently confused with a Skinner box for humans. Public rumors suggested he was experimenting on his child or that she became mentally ill. These are factually incorrect. The air crib was designed purely as a labor-saving device for parents to keep a baby warm without the need for heavy blankets, which could be a safety hazard. Deborah Skinner grew up to be a successful artist and has repeatedly written articles debunking the myths, confirming she was never a lab rat and that the crib had no negative psychological effects. During World War II, Skinner's research took a turn toward military application in what became known as Project Pigeon. At the time, there was no such thing as a missile guidance system. Skinner proposed that pigeons could do the job. He placed 3 pigeons in the nose cone of a Pelican missile. Each bird was in its own miniature operant chamber with a screen showing the view from the missile. The birds were trained to peck at the center of the target on the screen. If the target moved off-center, the pecking would signal the missile's fins to adjust its flight path. Despite achieving a high degree of accuracy in trials, the National Defense Research Committee eventually canceled the project in 1944. The military officials simply could not believe that birds could be a reliable guidance system, even when shown the data. Skinner's work also led to the development of shaping, or the method of successive approximations. In the Skinner box, if you wait for a pigeon to accidentally turn in a full circle to give it food, you might wait forever. Instead, Skinner would reward the bird for just turning its head slightly to the left. Then he would only reward a quarter turn, then a half turn. By reinforcing small steps that lead toward a final goal, Skinner proved he could teach animals complex behaviors that they would never perform naturally, such as playing a miniature version of ping pong or reading signs that said peck or turn. In the 1950s, Skinner transitioned his findings from the lab to the classroom through the invention of the teaching machine. This was a mechanical device that used the principles of the Skinner box to educate human students. The machine presented a small amount of information followed by a question. If the student answered correctly, they received immediate positive reinforcement by being allowed to move to the next frame. Skinner believed this programmed instruction was superior to traditional teaching because it allowed students to move at their own pace and provided the immediate feedback necessary for learning, which a single teacher with 30 students could not provide. The scientific legacy of the Skinner box also extends into the field of pharmacology. Medical researchers use the chambers to study the effects of drugs on behavior. By observing how different substances change the response rates on various reinforcement schedules, scientists could determine if a drug was a stimulant, a depressant, or if it had addictive properties. If an animal would press a lever thousands of times to receive a dose of a drug, researchers could quantify the reinforcing strength of that substance. This provided a factual, data-driven method for understanding substance abuse that did not rely on subjective reports. In the late 1960s, a researcher named Bruce Alexander challenged some of the conclusions drawn from Skinner box drug studies in what became known as the rat park experiment. Alexander noticed that in traditional Skinner boxes, rats were isolated and had nothing to do but press the lever for drugs. When he placed rats in a large social environment with toys and other rats, their drug consumption dropped significantly. This did not disprove Skinner's mechanics, but it added a crucial layer of factual context. The environment surrounding the box is just as important as the box itself. By the time of Skinner's death in 1990, his influence had reached into almost every corner of modern life. We see the principles of the Skinner box in the token economy used in psychiatric hospitals and prisons, where patients or inmates earn points for positive behavior that can be exchanged for privileges. We see it in the field of applied behavior analysis, which is the leading evidence-based therapy for individuals with autism. Today, the most pervasive application of Skinner's data is found in digital technology. Software engineers and app designers use the exact variable ratio schedules Skinner perfected to maximize user engagement. The pull-to-refresh mechanism on a social media feed is a digital lever. The likes, retweets, and notifications are the pellets of reinforcement. Because the rewards are unpredictable, users develop a high rate of response and a strong resistance to stopping. We are no longer looking at pigeons in a wooden box. We are looking at a global population interacting with digital environments designed using the factual data produced by B.F. Skinner over 80 years ago. His experiments prove that behavior is a function of its consequences, and by controlling those consequences, you can shape the actions of any living organism. Thanks for watching, and don't forget to subscribe.